Okay, what we're going to do today is work on how to solve multi-step equations. So our directions are going to say, so you guys get to copy this, solve. Now that's all the directions are going to say, but we're going to add and check. And again, we're going to add show all steps. It's not about what you can do in your head because you need to give justification to your math. Meaning I need to be able to see what you're doing, and I can only see it on paper because I can't take you home with me. Okay? Even though I have a nice sized house, I don't have enough to take all 180 students or 85 students that I have, so you can justify what you were doing verbally with me. All right, so here we go. Ready? First problem. 2x plus 3 equals 11. So job 1, do I have any parentheses? No. Do I have any like terms? Remember, on a side is when I'm talking about like terms. No. Do I have any absolute value symbols? No. Exponents? No. So that means I'm done with step 1. Step 2 says, do I have any adding or subtracting going on? Yes. Okay. So tell me, somebody raise your hand, tell me what I need to do to get x alone step 1. Ryan. I love how he said subtract 3 from both sides. Now, remember that property we talked about that said reflexive property, something is equal to itself? This is when it comes into play. I've got negative 3, negative 3. Taking away 3 equals taking away 3. So I'm doing the same thing to both sides. So the result of doing that leaves me with 2x equals 8. Fabulous. However, x is still not alone. Lane, right. You're texting. Dude. Put that away. Yep, but it's supposed to be off. Guess what? You're on school loop now. Going to be on school loop. Me getting on your case. Okay, what goes on? What happens next? Kelly.
You divide 2 from both sides.
Okay, I have multiplying by 2, so the opposite would be dividing by 2. 2 divided by 2 is 1. 1 times x is x. There's that identity property. 8 divided by 2 is 4. Now, before I can go ahead and say, yep, I agree with that answer, I'm going to do my check. And the check replaces, substitutes in for x its value, and checks to make sure if what's on the left actually equals what's on the right. So I have 2 times 4 is 8. 8 plus 3 is 11. Since 11 equals 11, that says, yep, you were right, x equals 4. Okay? Number 2, y over 5 minus 6. So one of the things I did talk to you guys about in this chapter, one of the problems that I saw on the test is you guys are putting your variables in denominators. You are showing multiplication below when you shouldn't be. It should be up high, so you need to really pay attention to those things. Okay. Do I have any parentheses? No. Do I have any like terms on a side? No. Do I have any absolute value symbols? No. Do I have any exponents? All right, then I'm ready to go. What's my first step, Robert?
You times 5. No, you plus 6 to both sides.
Thank you for getting to the both sides. And we're going to use the word add. We're going to add 6 to both sides. Well, it's a little pressure being, famous now. Y over 5 equals 15. Is y alone? No. So what is going to be my next move? Let's see. Somebody I haven't talked to. Cassandra will let you.
You need to multiply by both sides.
We're going to multiply both sides by 5. And remember, it shows up high. It could be to the right of the numerator or the left of the numerator. That doesn't matter. Now, I am going to show it below this number here because I actually have to do that multiplication. So let's see, the 5's cancel out, and that gives us a y. And then we get 25. 5 times 1 is 5 plus 2 is 7. So now I'm going to go ahead and do the check. And let's see what we get. We go back to the beginning. Oops, sorry. Try that again. No. So we've got y is 75 over 5 minus 6. Does that actually equal 9? And let's see. 5 goes into 7 once with 2 left over and into 25 5 times. And 15 take away 6 is 9, though I saw a lot of people on the test told me a question like that. The answer was 11. You can only subtract from one direction. If you got 11, you subtracted 5 from 6, and then 1 and 0, and that doesn't work that way. Since it does equal that, that says, yep, your answer was y equals 75. Okay, another one. Ooh. What's interesting about this one? 28 equals 13 minus 3a. Okay, Dory, what's weird about that?
The other way.
Yeah, what is it that we want to see when we're solving an equation?
You want to see the A on this side and then
Which side? Use words.
on the left side.
Okay, so we want, in general, a variable on the left side.
Yeah.
So is there something we've learned that allows us to rewrite this equation so that the variable will begin on the left side? Is there something we've learned that will allow us to do that? Okay, Craig, you remember?
The symmetric.
You got it, buddy. Let's put that in there. Symmetric property, pepper, blah, blah, blah.
Sorry.
Because I'm thinking pumpkin, because I'm looking, that's really a pumpkin-y color. What the symmetric property says, when you have an equation, you can pick up the left side. Notice I'm not changing the order of the terms on the left side. That would be commutative property of subtraction, which does not work, equals 28. Okay? All right, now, ooh, this is going to be a smarty person who gets this one right. What's my first parentheses? No. Do we have any like terms on a side?
No.
Do we have any absolute value symbols? Do we have any exponents?
No.
Okay, we have none of that. All right, Tina, what do you think I'm going to do on this one? Okay, wait a second, Tina, I'm confused. Didn't it say subtraction in the problem, and now you're telling me to subtract, so it would be the inverse of subtraction? How is that right?
Because the 13 is positive.
Smarty pants! Yes. The whole point to this is that example I was talking about. We want to get rid of 13. He's positive. The only way to get rid of something positive is to go the opposite sign. So we're going to subtract 13 from both sides. Notice that when I show my work vertically, it's really easy for me to track things. Now, what do you think a common mistake is? What do you think most kids want to write?
Add
They'll write just a positive. No, they won't add 13. Ashley?
They won't keep the negative.
They'll forget about the negative in front of the 3a. That's super important that he's still there. So we get negative 3a equals 15. Okay, now the problem becomes pretty simple. Jade, what happens next?
You divide -3 by on each side.
Okay, what we say is we divide both sides by negative 3. That's the weird terminology when it comes to division. Okay, so we get a equals, signs are different, answer is going to be negative, and 15 divided by 3 is 5. So we are going to do a check, because that's always a good thing. But here's the deal. The check goes back to the original problem, because what if you wrote 13a minus, or 3a minus 13? You would not catch it if you went into the one that you rewrote. So we always go back to the original problem. And let's see. What's negative 3 times negative 5?
15.
Positive 15. And I get 28 equals 28. Since that's true, that says, guess what? A actually does equal negative 5. Okay, I'm going to flip over to the next screen. Is everybody ready?
Mm-hmm.
Yes? Number 4. 15n minus 13n plus 14 equals 0. Do I have any parentheses?
No.
Do I have any like terms?
Yes.
Woo! Finally, we have something we need to do. So that's actually our first step, is to take care of the like terms. What's 15n take away 13n? 2n. And I write out the rest of the problem. Okay. Do I have any grouping symbols, any like absolute value or exponents left? No. So this looks like the problems we've been doing. Cameron, what am I going to do next? Cameron S.
You have to subtract 14 from both sides.
We're going to subtract 14. Yeah, we want to get rid of that constant first. Since he was positive, we're going to subtract him. So it gives us 2n equals negative 14. Okay, Molly, what goes on now?
No, we divide 2
We divide 2 from both sides. I know, the language is weird. Math does have language. We do have to follow protocol. So its signs are different, so I'm going to get a negative answer, and 14 divided by 2 is 7. So again, we're going to do a check, and we go back to the original problem. And is 15 times negative 7 minus 13 times negative 7 plus 14, does that actually equal 0? So let's see, we get a negative here, signs were different. We get 35, 7 and 3 is 10, so I get negative 105. A negative times a negative, though, is a positive. 7 times 3 is 21. 7 times 1 is 7 plus 2 is 9 plus 14 equals 0. Now remember we talked about if we have a chain problem, one of our strategies was group all the negatives, group all the positives, and then do a subtraction of the remainder. So that's what I'm going to do. I'm going to combine those guys up. And let's see, 4 and 1 is 5. Oops, that's supposed to be a plus sign. 4 and 1 is a 5. 1 and 9 is a 10. Oh, look at that. What do we call negative 105 and positive 105?
Inverses.
They're additive inverses, or its nickname is opposites. Yeah, okay. Looked like I was going to throw up, didn't it? Ugh. Actually, we had a kind of a joke the other day in geometry class. We were talking about a relationship between two lines, and the relationship was the lines were skew, and she said spew. I'm like, I don't think the lines throw up, but that's okay. There's so many words in our head sometimes. All right, so this problem. We got 3 times the quantity x minus 5 plus 19 equals negative 2. So do I have any distributing that needs to take place?
Yes.
Oh, finally we do. So we're going to distribute. We need to multiply 3 times x, which is 3x. And then we're going to multiply 3 times negative 5, which is going to give me a negative 15. And then I'll write out the rest of the problem. Okay, parentheses are gone. Do I have any like terms? And the answer is yes, I do. So I deal with them next. And I have 3x, and then the signs are different. Bigger numbers, positive, and 19 take away 15 is 4. Okay, now the problem becomes recognizable. We have no more things we have to contend with. Okay, what would be my next step to do? Hannah W.
Subtract 4 from both sides.
Very good. We're going to subtract 4 from both sides. And when we subtract 4 from both sides, we get 3x equals, signs are the same, so I add and I get a negative 6. All right, and then we'll go back to pumpkin. Hudson.
Divide 3
From where?
from both sides.
From both sides. We got to treat them equally. That's why these are properties of equality, because we're treating them equally. So we get x equals, signs are different, we're going to get a negative 2. So let's try the check and see if 3 times the quantity negative 2 minus 5 plus 19, does that actually equal negative 2? So inside the parentheses, I have signs are the same, so I'm going to add and I get a negative 7. 3 times a negative 7 is a negative 21. Signs are different, bigger numbers negative, 21 take away 19 is 2, and sure enough, it works, so that verifies, yep, x equals negative 2. Awesome timing, guys. Have a great day. I'll be here after school.